Okay. Welcome everyone. Welcome to the Rubin Science Assembly today. So today we have Elena Sapi, who will talk about the Gemini rapid follow-up program. But we'll start with a quick announcement and introductions as usual. Okay. So announcement, Rubin Observatory reveals over 11,000 new asteroids, and this discovery has been submitted to the Minor Planet Center. Um, and as many of us already know, alerts are flowing now as of 20 February 24th. And those are the latest news from the Rubin Observatory. But you always can check the news from the observatory on the website news tab, the rubinobservatory.org/news. And then in the week of June 22nd, there will be annual Rubin Data Academy. So this is fully virtual event, and this is mainly designed to help the new to the Rubin person or students to really get familiarize them with the Rubin data products and the science platform so they can start their science with the Rubin data. And then in the last week of July, we'll have Rubin Community Workshop this year at Slack. And then tomorrow is the abstract and the session suggestion deadline. So if you haven't submitted yours yet, please do so by tomorrow. And if you want to stay close to the meeting venue, the Slack guest house booking deadline is May 11th. There is the room capacity, I think it's like 100-ish. So if you haven't done booking the rooms, then that's the deadline. And roughly after a month after that, or deadline for the alternative hotels booking is coming. So this is not at the campus, but nearby the campus. And then registration deadline is June 22nd. And on the right, I show the upcoming Rubin Science Assemblies. So this week we have followed with the Rubin Observatory presentation, and next week is the final broker presentation by SNAP's team, which is the solar system broker. And after this, we will alternate every the other week between the drop-in sessions and the tutorial sessions as usual. And after the Rubin Sciences Rubin Community Workshop, in the following week at Slack, the same venue as RCW, there will be another workshop as gonna discuss about the like future of the Rubin Observatory after 10-year survey. And then the end of September, LSST at Europe is happening. And then in November, LSST at Latam is happening. And the Rubin Users Committee is really looking for your feedback. They are open to listen from the community about the Rubin data products in the science platform. So they are writing, reports twice a year, and that directly goes to the Rubin operation directors, and that's including, recommendations for improvements about those services we're providing. And next meeting is Monday. So, and then they will start with the listening session. So if you have any things to share with the users committee, what we're doing good, or what you want to improve, that's a good opportunity for you to share those things with the users committee. And the link frameworks office hour is happening most Thursdays right after this Rubin Science Assembly. So if you have any missions to enable, you by developing scalable and productionized softwares and algorithms to work on the LSST data, then this is a really good place to ask some helps and ask questions. Right. So I'm not, Melissa went over these slides multiple times so far, so I won't go details, but the prompt products will be is available actually. It's a real-time, near real-time process data release within minutes, the dates of images taken. So alerts will go through the brokers, and that is the notification of detected sky changes. And um, Elena will talk about how the Gemini Observatory will respond to those alerts. So with that, let's welcome Elena, and floor is yours. So you can share your screen and start your presentation.
Thank you, Yumi, for inviting me for the opportunity to present the Once in a Rubin's Gem DD initiative. How much time do I have?
Until 10.
Okay, cool.
Yeah.
So then I will actually take the opportunity to present Gemini in general to the community in case people are not familiar with it. Okay. So let me start sharing my screen. Wait a second. Okay. Do you see the presenter mode?
Yep.
Okay, perfect. Okay, so the Gemini Observatory consists of two telescopes. One is in Mauna Kea and one is in Cerro Pachon. And the observatory is a partnership of 5 countries. We have the United States, Canada, Brazil, Argentina, and Korea. And in addition, because we are sharing the ground with Hawaii and Chile, we also have them as our contributing partners. Everybody from these countries can apply to Gemini, and then because United States participate to the Open Sky initiatives, actually observers from around the world, everywhere around the world can have access to some time and some of the observing mode, some of the proposal initiatives that we offer, and I will go through that later. One of the strengths of Gemini is that because of our strategic location on the globe, we can cover the entire sky. 40% of the sky, that is the area covered here in light azure, is seen by both telescope. And because of the difference in latitude, we can also follow targets that are in this zone for a very long time. So if you need to have a prolonged monitoring of a rapidly evolving target, we are very conveniently located. Or if Rubin discover a target toward the end of the night, we can still observe it quite rapidly from Gemini North, even if it's not visible anymore from Gemini South. We are very proud of the infrastructure we have to follow up target of opportunities. We have a very effective queue mode that allow us to be on sky as fast as 15 minutes from triggers if you need so. So we can both support rapid TO that need to observe the target within 24 hours and standard TOs that are okay to follow up the target within 1 week. In all the facility instruments can be requested for these initiatives, and we provide the templates for you to prepare in advance so that you don't have to panic last minute figuring out what you want to do. And of course, I don't have to tell you what is the broad science cases that you can cover with a Rapideo, but we can go from interstellar visitors that are moving rapidly across the sky and objects that are rapidly fainting, but was position remain stable. We have a very healthy and flexible set of instruments on our telescopes. We cover optical and near-infrared observations, and we offer imaging observations with a field of view of up to 5 times 5 arc minute. These are the field of views of our imagers in the optical, the blue square GMOS, and in the infrared Flamingos 2 in Gemini South. And then we also, for spectroscopy, offers various flavors of long slit, IFU, multi-object spectroscopy, and you can use low, intermediate, and high resolution. This is the parameter space covered by the spectrograph that we are currently offering at both telescopes. We also have a very healthy visiting instrument initiative. We offer speckles observations with SOR and Alopeke. One Alopeke is at Gemini North, SOR is at Gemini South, and these allow us to offer you diffraction-limited imaging at optical wavelengths. And also we have a fantastic, extremely precision radial velocity instrument, Maroon X at Gemini North, that is specifically designed to characterize rocky planets around the red dwarfs. So at Gemini North, we offer GMOS, which is an imager, long slit, integral field of view, and multi-object spectrograph. We also have Alopeke, our speckles instrument, and Maroon X, as I just mentioned. In the infrared, we can cover long slit cross-dispersed spectroscopy with Generis that arrives to the mid-infrared. iGreens 2 is our high-resolution near-infrared spectrograph that offers simultaneous H and K spectroscopy. And we also have natural guide star AO, natural guide star and laser guide star AO system Altair that can work with Generis to give you either super seeing observation or diffraction limited observations with the IFUs. In the Gemini South, we have the twin GMOS. So again, you can do imaging, long slit, integral field of view, and multi-object spectroscopy. The twin speckle instrument of Alopeke is SORO. And then we have a high resolution, sorry for the typo, Excel spectrograph, GHOST. And Flamingos 2 is our infrared instrument that is both imaging, long slit, and also multi-object spectroscopy. For GMOS, going in detail, both Gemini North and Gemini South offer you imaging in U, G, R, I, and Z filters. You have IFU with field of view 5 times 7 and 5 times 3.5 arc seconds. The multi-object spectroscopy, it's you have to plan your own mask, they get cut, and this is how an example of how you can distribute your multi-slit on your target, and the field of view is very broad. And the wavelength coverage, you will have to, of course, is not continuous, but it's quite healthy. It goes from 0.36 to 1.3 microns. The science cases are as broad as you can imagine because this is a very flexible instrument. And GMOS is always available for observation. So if you, it's one of the favorite instruments for target of opportunity studies. Generis goes from 0.8 to 5.4 microns. It offers long slit and cross-dispersed spectroscopy. It also has IFUs in the blue and the red bands with low and high resolution configurations. And these are examples of spectra taken with the Generis. And recently we were able to combine Generis with, to bring back Generis AO observations also with the red camera that was not available in the past for IFUs. Moving to Gemini South, we have Flamingos 2, which is a near-infrared imager with a field of view of 6.1 arc minutes. The spectroscopy ranges from 0.9 to 2.4 microns, with the resolution varying from 300, with the resolving power ranging from 300 to 4,500. And you can do multi-object spectroscopy on a 2 times 6 arc-minute field of view. At Gemini South, we have a spectacular Echelle spectrograph with a resolution ranges from 50,000 to 75,000, depending on the mode you choose to observe. In single mode, we can have the highest resolution, but we can also observe 2 targets simultaneously. And in just 1 hour, we can get signal to noise 30 for a 17 magnitude source. And this is quite impressive considering the resolution of the spectrograph. The spectrograph covers simultaneously the entire range from 363 through 950 nanometers. So really a powerful instrument that is very exciting if you're interested, for example, in stellar astrophysics, binary studies, exoplanet characterization of atmosphere and the winds, but also if you want to do the chemical characterization of galaxies nearby. This is GNIRIS when it operates in AO system, and this is the performances in low resolution and more recently in high resolution. We were able to observe Titan, and you can see that we can definitely trace the variations in the surface of the moon with GNIRIS. If you're interested in very high resolution imaging, then in the optical wavelengths, then your instrument of choice are Alopeke and SORO. Alopeke is on Hawaii and SORO is in Chile. And this is the comparison of the performances of our Speckles instrument with HST and near infrared diffraction limited observations. So you can see that actually we are performing better than these instruments. And that is because we have a diffraction limited instrument at visible wavelengths on an 8-meter telescope. The price to pay is the sensitivity. Speckles observations are taking very short exposures and one after the other. And this means that you are limited to something of the order of magnitude 18 and 19 for your targets. But Zorro was able to finally confirm that A1 was actually a binary star with a tiny companion that was speculated for a long time in 30 Dorados. So, right, we can do science also in nearby galaxies with this instrument. Maronex, as I said, is our extremely precision radial velocity instrument. It is a world-class capability in terms of performances. And recently, it was the instrument that, combined with Espresso, was able to confirm that the Bernard stars host a four-planetary system. This was a very daunting campaign. It requires 3 years of observations and hundreds of observations to be combined together to confirm that these 4 rocky planets were present. But it would not have been possible without instrument of this stability and sensitivity. And the resolving power is 82 to 88,000. The wavelength coverage is 0.5 to 0.9 microns. And we have radial velocity precisions that are of the order of, actually, this is wrong, of the order of tens of centimeters per second. So these are the instruments that are currently on the telescope, but we are also working to bring new instrumentation on Gemini. The first instrument that will arrive at Gemini South is Scorpio. And then we are going to have GPI-2 in Gemini North and Guillermo's at Gemini North. Scorpio is an 8-channel imager that can simultaneously obtain observations in G, R, I, Z, Y, J, H, and K band. And it is also, and the field of view is a 3 by 3 arc minute. It also provides long-slit spectroscopy with resolution 4000 simultaneously from 0.3 to 2.3 arc minutes. And the exposure time are adjustable for each band, so you can get the best signal to noise at all wavelengths. The Scorpio was built with LSST in mind, was planned with LSST in mind. And so this is the performances of Scorpio, highlighted by the red lines, compared to Rubin in the analog wavelengths. And then you can see that we add the infrared counterpart that is currently missing in LSST. The dashed line are the performances in spectroscopy. So you can see that in just 1 hour, you can actually target quite faint objects if you're interested in characterizing, for example, the chemical characteristic of a supernova or a tidal disruption event and so on. We are interested in bringing also extremely high resolution to really appreciate the details of sources in Gemini North. We are upgrading our AO system so we will replace Altair with GNAO. This is the result of a NSF grant that was called Gemini in the Era of Multi-Messenger Astronomy. GNAO both support wide field correction over a 2 arc minute field of view. So in this case, we get super seeing observations. And then we have a narrow field mode where we can get diffraction limited performances over a 20 by 30 arc second field of view. The instrument that will work with the GNAO is GEARMOS. This is an instrument that is designed and developed by Canada. It allows to have imaging, diffraction limited imaging over a 2 arc minute field of view. And then it operates 4 IFUs that can be distributed over the field of view. So you can select single targets, or you can bring all the IFUs together in what is called a tailed observing mode. And in this case, you will cover something of the order of 20 arc seconds squared. GEARMOS support 2 resolving power, 3000 and 8000, which is quite an impressive resolving power for IFU in the infrared. And in imaging, we will cover Y, J, H, and K observation plus assorted narrow and medium band filters. The targets are, of course, high redshift galaxies to follow the formation and evolution, but also mergers of supermassive black holes, galactic, kinematic, and mergers. This is one of the powers of GEARMOS. We can, with the diffraction limited power of Gemini, resolve the internal structures of galaxies, for example, at cosmic noon, and with the 8000 resolution, really trace their internal kinematics and chemical evolution and variation. So this is a very exciting mode. Of course, in the local group, we are extremely powerful in studying star formation in regions that are particularly obscure and embedded. Things, for example, the massive star forming regions that we have in the galactic center, and then, of course, the kinematic and chemistry of star clusters and objects in the solar system. This is the sensitivity of GEARMOS compared to other infrared instruments. And you can see that in the overlapping areas, there can be extremely powerful synergies, for example, with GEARMOS, NIRCam, and NIRSPEC. The next instrument that we are bringing to Gemini is GPI-2. GPI-2 is an upgrade of GPI that in the past was operating at Gemini South. GPI-2 will be at Gemini North. These are the results that were obtained monitoring a famous planetary system, one of the first planetary systems discovered around stars. And you can see that the long monitoring allowed us to follow the motion of the planets around their host stars. But also, GPI-2 provides polarized lights. And so you can study the properties of protoplanetary disks and debris disks around stars in the near infrared. You have multiple ways to apply for time at Gemini. We have regular programs that are announced, that the call for proposal is announced every 6 months. We just closed the cycle 26B call for proposal in March, and we are having the TAC around this time, actually. The proposals are reviewed by the national committees, so you have to apply to the partners of your affiliation. If you're not part of any partners member, then you apply through the United States TAC. And these are the routine programs that can be planned over a long time and they can be scheduled. If you want to do TOOs, you can actually apply through these venues, just saying, I am planning to observe the next 10 supernova that will be discovered by LSST next semester. And these observations are scheduled in Q and classical mode. We recommend the Q mode because you are going to get the best sky conditions, of course, for your observations, and you have the higher probability that your observations will be visible and feasible at the best time. If you have ambitious programs that require a long amount of time, long monitoring, or a large number of targets, then, and if you have an affiliation with Canada or US, then you can apply once a year to the large and long programs. These programs are done in queue, and the important thing is that the PI has the affiliation with the US or Canada, but COIs can be added from any institute. Their affiliation, it's not, there is no blockage for the affiliation of the COIs. Every month, we have what are called the fast turnaround. You apply for something that will be executed 3 months after the review program. So, the reviews are done by the other participant to the applications. And these usually are small programs. The number of hours available, in general, we approve programs that are of the order of 4 or 5 hours, but we had also programs that were approved for time requests of the order of 10 to 15 hours. These observations are executed in queue. And then if you can always apply at any time for DD time. The approval is done by the chief scientist. The reviews are done by a small committee. And these are for special opportunity, very rapid things that will disappear too quickly to be included in the fast turnaround and so on. And finally, at any time, you can also apply for poor weather. We have a special form that says these are poor weather observations. The request will go to the head of science operation that will review if the observations can be scheduled depending on the queue, and then you will get your time. So that is not even like you just need to be fine with not perfect weather conditions. Okay. So our proposals are done in a dual anonymous review process, and that was added to reduce the cognitive biases. And this is how the distribution improved following the introduction of dual anonymous procedures. Once your data are acquired, they are stored in the Gemini Observatory archive. The archive includes all the raw data and the calibration data for all instruments, but we are now also offering reduced data for GHOST, GMOS long slit, IGRINS 2, Zorro, and Alopeke. For Zorro and Alopeke, the data reduction is done by the visiting instrument team. For GHOST, GMOS, and IGRINS 2, they are provided by Gemini. Marunex observations are also reduced by the Marunex visiting instrument team. Currently, the format of the observations for Marunex is not compatible with the archive, and so the PI gets the observation directly. If you are interested in observations that were acquired with MaroonX, but they are not, but you are not the PI, you can contact Gemini, and we will, if the data are not under proprietary time anymore, we will give you the calibrated observations, the reduced observations. Our calibration pipeline is Dragons, and it is a Python-based data reduction system that is supporting at the moment imaging and long slit observations for GMOS, GNIRI's long slit, and the cross-dispersed spectra. They are also now, you can also apply now the, oh my goodness. Atmospheric telluric line with Dragons. Ghost is fully reduced with Dragons. Flamingos 2 imaging and long slit are now available, and long slit is a very recent addition. We actually added it this month, and that is because Dragons is in constant development and expansion, and so we are planning to bring more observing mode to Dragons as we progress. In the meantime, you can get you can reduce the other observing modes that are not covered by Dragons using Gemini IRAF. And if you need help with any of the reduction, you can contact the help desk, or you can also contact the instrument scientist if you need help, for example, in planning your observations, in improving your observing strategies. Now, if you are interested in time domain, we are greatly improving our support for time domain. Well, the upgrades were made with time domain in mind, but they will benefit every time of observations. So this semester was the last semester that people submitted their observation using the PEAT system and the OT system to plan their phase 2. Starting next semester, we are going to use the Gemini Observing Platform tool that is fully integrated. It will allow you to plan your phase 2 immediately, and so you will submit the entire program in one shot. But the tool is really planned to be friendly and intuitive for the users and avoid the confusion and mismatch that we had in the past. It is also supporting the entire operation of the observatories, and it is particularly smart in optimizing our schedule on the telescope so that we can really meet and match the best observing condition for your proposals. And in particular, it is particularly smart in bringing on the telescope target of opportunity. So now we can quickly respond to your triggers, but the new tool will be even faster and better optimized. In addition, we have GOATS, that is a browser-based user interface that allows you to use in one spot all our features. So you can get the broker alerts through, you can filter the broker alerts through GOATS, and then plan your observations with GPP, reduce your data with Dragons, but also leverage on the tools that are available through Astrolab to do further data analysis on your results. And once you have analyzed your observations, you can also plan for further follow-up through GOATS and submit further observations. So in general, with these complete ecosystem, we demonstrated about 1 month ago that you can go from trigger to reduce data in something of the order of 1.5 hours. So it's really a powerful infrastructures, and it will become live. It will go live next in September for the planning the observations, submitting your next proposals, and then we will start to operate the telescope under these infrastructures in February or March 2027. Okay, so moving forward, the last thing I would like to cover is a special director discretionary time initiative that is called Once in a Rubin Jam. Gemini South is on Cerro Pachon, side by side with Rubin. We are literally seeing the same sky. And to take advantage of this fantastic collocation, we are offering, at least to start, 120 hours of DD time that are distributed over 3 years. The idea is to create a framework where we can really support a rapid response to the unexpected discoveries, the most puzzling, surprising discoveries of LSSTs, and to capture their early evolution and put you in the condition to really plan for the best follow-up once you better understand what's the origin of these systems. The idea is that with Rubin providing millions of triggers, of alerts, and having limited telescope time for each of you to follow up, we can give you another way to really understand what are the precious, how to invest the precious hours that you have of telescope time on these targets. These observations will have no proprietary time, so everybody will have access to these observations immediately. And at the moment, we have more than 150 subscribers that helped us in defining the triggering characteristic and the observation strategies. But they are also part of the mailing list, so of our mailing list. The reason why we started this initiative is that typically a DD request, even when it is clear that it is a very urgent target, requires a number of days before you can go on Sky. You submit your request, we evaluate it, then you have to design your observations, then the observation goes on Sky. This means that best case scenario, you get on Sky between 5 and 7 days from when you submitted your observations. And we want it to be faster in case it's needed, right? Some of these targets may disappear in just a couple of days. You don't want to waste the time for us in understanding if this is a valuable target or not. We have identified 4 scientific fields: solar system, galactic, extragalactic, and fringe cases. The request for these observations are done not through the regular form, but using a Google form that is available on our webpage, and you can use the QR code to find the page, or just Google Once in a Rubin Jams, and you can actually find the page. We are supporting a number of observing modes that were selected to make sure that these instruments are available on the telescope. These are the most common observing setup that we have, and so you have a very high probability that your observations will be taken if you use one of these setups. Because we want to make sure that we are fast in our response, we have pre-prepared the observing strategies for you, and what you need to provide for us is the exposure time, the configuration mode that you want. You will choose from a list of configuration modes available, and the coordinate of your target. We are going to put that information in the modes, and we are going to mark the observations as ready to go, and they will go on Sky immediately. If, of course, your request is considered, is approved. The requests are reviewed by a committee of experts that were selected by the working group. So they were deemed, they volunteered, and then the committee said, we want this person, we don't want, the working group said, we want this person, not the other person. Once the observation is approved, if you are, oh my goodness, there is another typo, okay. If you are on our mailing list, you will get an email when the observations are triggered and an email when the observations are concluded. So you can always be aware of what is going on with this program. we support two flavors for our request. One is within 24 hours from your trigger, and the other is within 5 days from your triggers. We do not allow super disruptive requests where you're saying interrupt everything that you're doing and do my observations. And that is because you can ask for that, for example, in your regular TO programs. But when that happens, you have to pay back the observing time to the observations that were interrupted. And so in this condition, we decided to avoid that, at least for now. This is an evolving programs. We are monitoring we will be monitor how the programs develop, and we will collect feedback on how we can improve the strategy. We plan to change how we are following up the triggers as new instruments become available and as we learn better how LSST operates. So these are the rules that are in place now. They will change moving forward. So another reason to register on the mailing list is that you can tell us how we can improve what we're doing. And with this, I'll stop it here and I'll take questions if there's. Yeah.
Thank you, Elena. So there is already one question in the chat. So the question was, would proposal submitted by an amateur astronomers or independent researcher be considered for review?
You mean for this one? Yes.
Yeah, I think so.
Yes.
Alert. Yeah.
Yes, you can submit the proposal. In the program, it says, it asks you to provide a justification why why you want to observe this target. Another important point is that this is a program that was specifically planned for LSST follow-up. And so you will have to include also the LSST alert that the LSST ID alert, so that we can also go and check what is the target, especially if there are targets that maybe were, it turns out to be spurious or something. We can have that second way of checking. It's also important that you provide the coordinates for your target, because we expect that, especially if there is a target that is going to fade rapidly, it may trigger multiple IDs, and we may get multiple requests from different people within a few hours. We expect that the fact that they are coming roughly at the same time or within the same day will help us figuring out that it is the same object, but we want to cross-check and make sure that we are not repeating 10 times the same observations on the same object and use all the DD time on that. Because per semester, the amount of time is not large. On the other hand, if we find that this is a successful initiative and you guys liked it, we can go back to the director and ask for more time and say that actually it's very successful. Let's continue to do that.
Okay. Questions for Elena? Can I ask one? So you mentioned time for the rapid follow-up. You mentioned the time range between like 10 minutes to 24 hours. And what are the factors dictating the follow-up time delay?
Okay. So in general, if you have a regular TO program, if you have an approved TO program for rapid TOs, the agreement is that we will execute your observations within 24 hours from triggers. However, you can say that this is a very disruptive program. You need to be in sky immediately. And so if you do that, that means that within 15, 20 minutes, we are interrupting from your trigger, from the time you trigger, we are interrupting what we are doing, and we are going to take your observations.
Mm.
If you do so, the cost for you is to pay the extra hour. So if there was a planetary transit that was 7 hours, you are paying 7 hours out of your TO program for something that might be 20 minutes. It's right. You need to be ready to make that trade-off. If instead you say, I can wait 5 hours, it's okay, you can finish your observations, then we are going to schedule your observations in the first window possible. So if, for example, there is an imaging program that's just taking multiple observations, but they can be interrupted, we are going to stop, take your observations, and go back on target, and you don't pay anything in that case. So it's really that type of difference. And you might be lucky that you trigger at the time that we are just finishing and you go on time anyway.
I see, I see.
But yeah, so that is really the main difference.
Mhm, mhm. Any other questions? And I have one more question.
Okay.
So you said this is a just an evolving program. So you currently have 120 hours over 3 years. Would that be spread out like more or less evenly in each year, or?
Yeah, so at the moment it is evenly spread out, so it is 20 hours per semester.
Mhm,
And you can apply both for Gemini North and Gemini South. Because of how our scheduler works at the moment, we have 15 hours at Gemini South, 5 hours at Gemini North, but that is just a placeholder. We can actually
mhm,
move a time north and south.
mhm,
So, and if you like it, and if we demonstrate that there is values in this type of approach, we may extend it for longer years, and we can make the case for a larger time, right?
mhm,
So this is an experiment. Let's see how it works, and
mhm,
maybe if we get from the community, this is how we want to operate, give us 100 hours
mhm,
per semester that is to be distributed across the entire partners. Right? You can write a large white paper for the director and the Gemini board to consider, and you can make the case. We'll see, right? It's uh, there was a suggestion in the past to try to encourage this type of the initiative for time domain
mhm.
at one of the conferences that we had here in Tucson a couple of years ago. This is a way to see if it works, and then if it works, it's up to you as a community to tell us how to operate it, and what we learned that was working in this process and what was not working, and so let's change it.
Great, thank you. Do we have any further question? If not, let's thank Elena again. And thanks
Thank
for
you.
coming and tell us about the program, Gemini program.
Well, I hope that you will consider sending your request.
Great. Thank you. See you next week.
Thank you. Bye bye.